Hello, I welcome you all in this presentation. This presentation is related with the subject fundamentals of the manufacturing processes, and we are talking about the casting process. And in the casting process, we have seen that there is a requirement of pattern. Pattern is used for making the molds and then melting of the molten metal, and the molten metal will be poured into the mold. Thereafter solidification will be leading to the development of the casting. So basically it constitutes the different parts like this: sprue, base, runner, ingate, mold cavity, ingate, and here we may have riser. So the molten metal will be filled in through this by the flow of the molten metal through the gating system. From the ladle, molten metal is poured into the pouring basin, then it flows through the sprue, then sprue base, then runner, and then ingate, and this is the cavity of the mold. So once the pouring is over, molten metal has filled the mold cavity. The molten metal will be rising in or will be filled in the riser, which will be used for compensating the shrinkage on account of the liquid to the solid state transformation. So in case of the sand mold, entire rest of the space is filled in by the sand. Here parting line may be here, and this is the cup portion, and this is the drag portion of the flask. So you see, after the solidification, once the solidification of the molten metal is over, the temperature will be coming down gradually, and finally it will reach to the room temperature, but it will take very long time to reach to the room temperature because the sand is of the low thermal conductivity. So we need to identify at what stage the mold of the sand should be broken so that we can take out the casting. So basically, to extract the casting after the solidification, this is the casting, to extract it from the mold, it is required that the sand mold is broken. So at which stage, means at which temperature the sand mold should be broken so that the casting remains intact and as per the requirement, means of the desired characteristics and quality. Because if the mold is broken at a high temperature, then it can lead to the breaking of the some of the parts which are thin in section, and it can lead to the wrapping or the due to the residual stresses, and it can lead to the cracking. So the correct temperature for breaking of sand mold depends upon three factors. The temperature must be low enough so that the differential cooling taking place in the different zones when the casting is exposed to the atmospheric air will be leading to the differential contractions. Say the casting is like this. So when after the breaking, the sand mold, when it is exposed to the air, so the different sections having the different sizes, so those which are thin, they will be cooled rapidly as compared to the other heavier sections. Similarly, the skin of the casting will be cooled at much faster rate than the material in the core. So because of these two regions, the differential contraction at the surface and the core leads to the development of the residual stresses in the casting, and this can lead to the cracking as well as wrapping or the distortion in the casting. So this is one aspect that the sand mold should be broken at a low temperature enough of the casting, so that not much of the differential cooling rates are experienced by the casting at the surface and in the core portion. Another thing is that no transformation should occur. The casting must be cooled down to such a temperature that thereafter, even if it is exposed to the air, there is no further metallurgical transformation. So, the temperature at which the mold should be broken should be such that no metallurgical transformations occur thereafter in the casting, so that it will not have any adverse effect due to the cooling rate. So, these are the two aspects. Further, if the casting is of very low section thickness, then during the breaking of mold at high temperature can lead to the fracture of the some of the sections, because at high temperature of the casting, if the mold is broken, then the thin sections of the casting may not be able to support the forces acting onto the casting during the breaking. So, that can lead to the either undesirable deformation or the fracture of some of the thin segments or thin sections of the casting. So, like for example, thin section castings of steel, these should be extracted at the temperature below 400 degree centigrade, while if they are of the heavy section, this can be done even at a higher temperature, because heavy section casting will not be breaking so easily. So, it can be 500 degree centigrade at which these need to be extracted. So, basically there are three aspects regarding the temperature at which the casting should be extracted by breaking the sand mold. These are like the temperature must be low enough so that there is no development of the residual stresses and no metallurgical transformation is involved there, which will be leading to the otherwise will be leading to the undesirable metallurgical changes in the casting, and the temperature must be low enough so that the thin sections of the casting can handle the forces acting onto the casting during the breaking of the mold. So, these are the 3 points regarding the 3 points must be kept regarding the temperature at which the sand mold should be broken, so that the casting can be extracted as per the required quality. Another thing that the molten metal present in the runner after the solidification, where will be having the metal which is metallurgically connected with the casting. So, one is in the riser, molten metal in the riser after the solidification will remain attached with the casting. Similarly, the molten metal in the ingate will also remain attached with the casting, and the runner will also be remain attached with the casting. So, basically we will be getting the runner attached with the ingate, this is the casting, and casting of the same shape, and this is the say riser. So, this is the solidified metal in the riser, this is the solidified metal in the ingate, solidified metal in the runner, and actually what we want, the casting is this much only. So, this is the casting which is needed. So, we may say this hatched horizontal lines indicating the casting which is desired. So, we need to remove all these portions related which are additional and not required with the casting, that ingate, runner and riser, these need to be removed. So, basically the removal of the ingates, risers and runner is needed because these are the metallurgically connected pieces of the metal with the casting in order to get the casting which is desired for end use. So, cleaning of the casting. Once the casting is extracted, what it involves? Cleaning of the casting. What are the things which are within the scope of this? One is, if the cores have been used for producing the internal features, holes, then this sand core needs to be removed. Then the ingates, riser, runner, metal solidified in ingate, riser and runner, this also needs to be removed. If the some fins, projections and additional metal deposited, metal at a parting line, or the sand fused on the casting surface, all these need to be removed. So these are the things which need to be cleaned, need to be removed for proper cleaning of the casting, so that it can be used. So we will be talking one by one about the approaches which are used for cleaning of the casting, for taking care of these three aspects related with the casting and cleaning of the casting. So removal of the sand core. We know that whether it is the dry core or the green sand core, when it comes in contact with the molten metal during the casting, all the moisture, if it is there, that will be moisture is removed. So basically we have the dry sand in the core. So in order to remove this, part of the clay in the core will be burned when it comes in contact with the molten metal at a high temperature. So basically the breaking of the mold, basically removal of the sand core is achieved by knocking off, by hammering the casting. This is one, so that the sand core automatically comes out of the internal features or the holes which have been used. For example, like say this internal hole has been produced with the help of this sand core. So this sand core needs to be removed. So by hammering this, casting gently will break the core inside the casting, and so the sand will automatically be removed. Another method, so knocking with the hammer helps in removing the sand core from the casting. Another one is the hydroblasting. In this case, jet of the water is directed onto the sand core, so that it is broken and cleaned from the internal features and the cavities which have been produced by this in the casting. So hydroblasting is just like applying the water jet in the core, so that the core can be removed. Core vibrator is also used in order to remove the core sand. So when the casting is kept onto the vibrating platform, so the casting the core is broken and it is automatically removed from the sand casting. So application of the core vibrators helps to break the core sand and thereby removing them from the casting. Now coming to the removal of the gates, ingates. So removal, because these are the extra unnecessary attached metals with the casting which needs to be removed in order to get the final casting which we actually want. So removal of the metal deposited in ingate, runner and the riser. So these need to be removed. So depending upon the type of metal, metal. For example, if it is cast iron, then it is hard and brittle as compared to the steel. So, the approach which is used for this purpose is different. Then the size of the gate or the riser, if it is thin or it is heavy section. So, accordingly we use the different approaches. For example, thin section cast iron, the gates and the risers are simply removed by knocking off with the hammer, knocking off the hammering the in gate and metal deposited in the in gate and the metal deposited in the riser. So, since the cast iron is hard and brittle, so when we hammer the riser or the gate, they will be broken. So, removal by hammering. So, hammering helps to break them easily, but in case of the steel if it is like say thin section steel gate and the risers can be removed by hacksaw or the bend saw. Simply cutting is performed and the bend saw, but for the heavy sections thermal cutting methods are used. Because if the section is really heavy, so we need to apply the heat so that the either oxygen assisted gas flame cutting or arc cutting can be applied. So, thermal cutting methods in form of like flame or arc cutting is applied for the steel castings which are of the heavy in section, while if they are thin, then hacksaw and the bend saw can be used for the cutting purpose. So, these are the approaches which are used for removing the gates and the risers. Additionally, for cutting purpose like cut off or the parting of abrasive wheels also used. These are basically the grinders which are very thin in sections, maybe 1 or 1.5 mm size. These will be rotated at high speed and workpiece, and the gates and risers to be cut, they will be pressed against the abrasive wheels so that the cutting takes place. So, apart from thermal cutting, hacksaw, the abrasive cut wheels are also used for removal of these risers, runners and in gates. So, like say in the casting, this is the section where cutting has been done in the casting, and this is the section where cutting has been done to remove the riser. So, the riser either if it is of the cast iron, so hammering would have been done, say, or if it is a steel, then the either flame cutting or the bend saw or hacksaw, whatever has been applied for removal of this or the parting of the grinder, and this is where the riser gate was there. So, if these have been removed by these the methods which I have just described, so these will be leading to the presence of the sharp edges in the regions where cut has been made. So, in both the locations there will be sharp edges and the surface will be rough. So, these will not be good for the use directly. Apart from that, like if the molding sand has had the poor refractoriness, then it will melt and fuse. So, some of the fused sand may also get attached with the casting. So, fused sand, this also need to be removed. If the sand mold had a coarse sand particles, then the molten metal will penetrate in those regions, and we will see that very fine projections are present in form of projections of the metal are present in the casting. So, these fine projections also need to be removed. So, these are basically penetrations or fine or fins or projections. These projections may also be there present at the parting lines in form of the like additional metal deposited at the parting line. So, parting line metal may also be running along the length of the casting, at the parting line. So, these need to be removed. So, parting line metals. So, if we see here the fine fins, projections or the penetration, all these are very thin in sections, can be easily removed by chipping off. Basically, so the chipping off means we can use the pneumatic hammer, hammer or manually means hand tools. Hand tools can also be used for chipping off these fine fins, projections or penetrations present in the casting in order to smoothen the casting. So, once these are removed, so all these the projections will be removed from the casting and we will get the smooth surface of the casting. But in order to remove the fused sand, we need to use we can use the two different methods. So, we are left with the fused sand. To remove the fused sand, basically the two methods are used. One is the sand blasting, or there is one more, sand or the steel grit blasting, and it can also be hammered for its removal. So, for the sand blasting purpose, what basically we do for the sand blasting purpose, one closed chamber is used and the casting is kept inside the closed chamber, and then high velocity compressed air is used, and this is mixed with the sand or the steel grit. So, these will be directed onto the surface having the fused sand. Not just the fused sand, but all the fine fins, the projections of the metal deposited at the parting line, all these will be easily removed when the sand blasting or the steel grit blasting is used. So, here compressed air with the sand particles or the steel balls is directed onto the surface having all these undesirable features like fused sand or the fine projections. So, these are removed with the impact, removed by impact of the balls or of the sand, and that is how it is cleaned. So, the chamber is basically closed, so that whatever is whatever dust, dirt, everything which will be flying here and there, that will be within the enclosed chamber. But the care is taken that operator who is working in the sand blasting is protected properly in order to avoid any kind of the harm to the worker or the operator who is involved in the sand blasting. Then there is one more and very commonly used method for cleaning the sand castings is the tumbling. So, tumbling, this is another very commonly used method of cleaning the casting. In this case, one very large the diameter barrel, this is say barrel, large diameter barrel having the opening in one side which can be open and closed. So, opening, gate which can be closed. So, whatever the castings need to be cleaned, the gate is opened and the castings are placed in this barrel like this, one over other, and enough space is kept empty in the barrel, so that when the barrel is rotated, the castings will the surfaces of the casting will be coming in contact with each other and they will be rubbing each other. So, in this process all the fins or the projections or the additionally deposited metal at the parting line metal, all those are easily cleaned. Even the fused sand, these are easily cleaned when the particles or the castings surfaces will be rubbing with each other, and this the barrel is rotated at quite low speed like 30 to 40 rpm. So, this is the kind of the speed which is used. So, continuous rotation of the barrel will be leading to the rubbing of the surfaces of the casting with each other and thereby removing all these things. So, after this we get the smooth surface free from fins, projections, etc. onto the casting, and very clean casting is achieved by this. Additionally, one more thing is done, that if the sharp edges in the casting produced due to like cutting or thermal like mechanical cutting like machining or the grinding or the thermal cutting methods. So, these sharp edges can be easily polished using the either depending on the size of the castings, pedestal grinder for the small size castings. So, basically the casting is held in the hand and the it is pressed against the rotating grinding wheel. Another method is that if the casting is really big in size, then the swing type of the grinder is used, which is pressed against the casting. It can be moved easily and brought near to the casting, and it is pressed against the surface which is to be smoothened or the finished. So, these were the different things related to the cleaning of the casting, and the entire steps like the cutting of the gates, risers, etc., removal of core or removal of the fins, projections, fused sand, and tumbling or the sand oblique steel blasting, ball blasting. All these are the steps related to the cleaning of the casting, and as a whole entire process of the cleaning of the casting is called process is called fettling basically. So, the fettling is the process of the casting, cleaning of the casting process, which involves, so fettling basically involves cutting of the gates and the risers, removal of the cores, removal of the fins and projections in the fused sand, tumbling, sand blasting or the steel blasting for removing the all undesirable features from the casting surface. So, now I will summarize the presentation. In this presentation I have talked about the temperature at which the casting should be extracted from the sand mold by breaking the mold, and once the mold is broken, then we need to remove the number of undesirable features which are present in the casting, say for example like removal of the gates and risers and removal of the fins, projections and undesirable materials which are deposited on the casting surface, so that the clean and usable casting can be produced. Thank you for your attention.